Hello everyone. This is a short hangout on air for giving a code walkthrough through the OVSDB repository in OpenDaylight. I I am assuming you are fairly familiar with OpenDaylight at this point. So this walkthrough is really focused only on the OVSDB repository, which you can download with the package name OVSDB. So in this hangout, I'm going to focus mainly on the plugin part of it. I will do another hangout later for the OpenStack integration piece. So for the plugin, I want to just go over the individual pieces. So essentially, everything except the OpenStack pieces are what we have in the OVSDB repository for the plugin. And as of now, there are a couple of extensions for the OpenFlow 1.3 to support Nicira resubmit commands and things like that. So ignore that for now. So in this figure, I'm showing the overall OVSDB repo right now. On the top, we have the OpenStack pieces. The OpenStack network is what integrates with Neutron, and OpenStack network providers are the ones that programs the rules and inserts all the L3 tables and things like that. And the network provider, it uses the Nicira extensions and also OpenFlow 1.3 to be able to program the switches. And both network and the OpenStack network providers, they also use the OVSDB plugin to set up the bridge, configure the controller, and things like that. So let's now focus on the plugin part. The plugin part essentially has everything here on the left. So it has a ADSAL based plugin, which means that there is no backend data store to which all the configurations are ported. Although now there is an extension which provides that support. I will talk about that shortly. So the OVSDB plugin, it works with on top of the OVSDB library to be able to make all the communication with the underlying OVS Open vSwitch based switches. And there is an outbound module that the latest version is version 3 that has code for interacting with the plugin to be able to perform certain actions and extract certain information. Now, one of the main things you need to realize with using Open vSwitch is that there are several different schemas. The top two ones which everyone uses right now are the Open vSwitch schema, which is where you have the bridge, you have the bridge tables, the port tables, and you have flow tables and things like that. And there's the hardware VTEP schema that is about how a physical switch maps to a logical switch. The Open vSwitch or the OVSDB plugin, as of now, really works only for the Open vSwitch schema and not yet for the hardware VTEP schema. So I will walk through the code and explain why that is, and I'll also try to show all the important components here. Before moving on, I just want to quickly show the schema. So the Open vSwitch schema essentially has different tables, and each of the tables have relations. Basically, any line means that Open vSwitch is the first Open vSwitch table is going to have in the columns, it's going to have a list of bridges. But then bridge itself is a table on its own. So the identifier is mapped to that. So like that, there are several different tables with dependencies, and this is the overall chart. And you can see that it is all structured with regards to creating interfaces, ports, associating them with the bridges and things like that. And there are also certain manager options which involve setting a manager for the overall global system and also being able to set controllers for individual bridges and things like that. The hardware VTEP schema is entirely different. It also has the manager concept, but except for that, everything else is very different because it's been streamlined towards doing VXLAN kind of switches. So to be able to support VTEP hardware, we have a concept of a physical switch connecting with the logical switch and being able to associate individual MAC addresses to different parts of that switch based on which interface it belongs to. And you can also associate certain VLAN identifiers to the interface. So the schema is very different. And if you think of creating a bridge on the Open vSwitch schema, there is no such equivalent here except creating a logical switch. So there are a lot of commands that are different operations. So it is important to understand the schema. Now let's take a quick peek into the code, and I'll come back again to this presentation. So here we have the library, and inside the library are the two schemas defined, or the base schema is defined here. You have the a concept of a typed table, which is what essentially everything uses to using template libraries to be able to preface exactly what kind of a schema we are working with. And all the underlying base operations are inside this library. For instance, the lib is what takes care of the OVSDB connection and handling the OVSDB clients and things like that. So all the implementations for that are here. I'm sorry, it's inside the implementation. The OVSDB client implementation and the connection service. They're all involved with actually working with the switch. Now let's go on to the schema. So you have two schemas, like I mentioned, the hardware VTEP and the Open vSwitch. And for all of them, individual tables have been defined, and all the individual fields have been statically coded. And this is how ADSOL works. So in the ADSOL way, all the individual tables are well defined. So you have the individual columns defined, exactly what data it exchanges, like you get a string and things like that. So everything is defined here, and they're all a type table. So this basically maps on with the library, and so eventually, if I do a for a particular schema, I do a get source map column, it will appropriately do the right call when it's sending it to the switch. So the actual wire protocol information is not necessarily here. It all just maps onto the JSON fields based on what names I have for the column and things like that. So yeah, one point I did not mention is that the OVSDB schema is a JSON-based format. So when you do in the command line a get schema, you'll see that everything is JSON-based. So similarly, we also have an Open vSwitch schema, and all the code written for modeling each of the tables for that here. You should be able to look at the manual for the schema to be able to understand each of these. But for most part, when you're using OVSDB plugin, you do not really need to know about this. So now let's come into the plugin part. The plugin has a bunch of files in the implementation, and these are really the backbone of the plugin. So let me jump onto this using a slide that I put together. So these are the three main implementation classes that you really need to know inside out if you're going to be modifying the plugin. First one is the connection service, which works to the library to be able to receive events whenever a new node is added, or if there is a table change and things like that. And as soon as a change happens, the connection service is going to make calls to the inventory service to say that a table has been updated or a new node has been added. The inventory service, it is going to basically send, whenever a change happens, it sends notifications to all the listeners about a row or a node being updated. And it also calls the configuration service to set an open flow controller if it's a new node addition. And the configuration service is really one of the biggest implementation classes inside this whole plugin. It is in charge of all the get queries with regards to getting any information from the database, and it also handles all the OVSDB configurations which are coming from higher level applications. And all of these are translated into client transactions, and it is sent down to the plugin, which will send it down to the switch. So this is the high level view of how these individual implementations work. And I have some information here which are essentially the same as what I have in the figure. So the main implementation, which is on the right side, the configuration service, it has a lot of different calls like insert row, update row, and things like that for manipulating the database directly. And this is what high level classes or high level applications like the OpenStack network provider and all of them use to be able to manage information on the switch. Now let's go into the code. So here is the configuration service, which has all the different functions. Like I said, it has the it has all the row operations. You have the insert row, update row, and all those different functions that are exposed. And this is what you would use from a high-level application to be able to make changes to the underlying bridge. And yeah, like some knowledge of the schema would be useful if you're going to be able, if you're going to make specific modifications to the bridge parameters and things like that. For instance, if let's say I want to set an OpenFlow controller. The OpenFlow controller, the first thing it does is it extracts a bridge, a dummy bridge, and then it sets the protocol to it based on what protocol we want to use. And if that bridge already exists, I'm going to do an update bridge. I'm going to do an update row to update the protocol. And then after that, I'm extracting the, so this is for setting the controller itself as the OpenFlow controller. So it gets all the IP addresses of the local controller IP address, port, and all that. And I construct a controller target information. The target is that string you would see as TCP:IP address :6633 or whatever. So that target information is set on the controller table, which is created, and then eventually you're doing either a update row or insert row based on whether there already exists a controller table with a particular row. So by doing these update row and insert row operations, we manage all the different information that needs to be programmed on the switch. And this could have been done inside the application, or it could be done inside the plugin. In this case, it's just a convenience function inside the plugin. But there is also code inside the OpenStack network provider to be able to set the OpenFlow controller from the application. In that case, it will make directly calls to the insert row to be able to do that. Now, the inventory service, like I said, is what keeps track of all the different configurations that have gone to the database. So whenever a change happens in the database, the connection service is going to send a note here saying process table update, and the process table update is going to look through the tables and it's going to appropriately update the cache. The table cache is going to be updated down here. And then once you update, you also send the information to all the listeners saying a row has been updated. So if you're building any other application that needs to listen for OVSDB changes, you need to implement this inventory listener. This OVSDB inventory listener is what you will implement, and then you'll get calls saying node added or row added and things like that. So the inventory service has here a DB cache, and this cache is almost reflective of what's there in the underlying switch, because we have a monitor operation that's configured, and whenever the monitor receives an event from the underlying switch, the table gets updated, and that gets updated in the cache. So essentially, the inventory service really is only about keeping track of the database and sending listener events. And the connection service is about programming the monitor for the database so that you can receive events whenever there's a change in the database, and also for initializing the inventory whenever a new node arrives. And so whenever a new connection happens, it gets all the information, and it makes a call on the inventory service to add a new node. So this is what the connection service does. So coming back to the PowerPoint, essentially these are three main implementations you need to know if you're working with a plugin: the connection service, the inventory service, and the configuration service. And if you know the schema, you can directly work with the individual row and column information to be able to update whatever is underlying, and you can program the switch. And now whenever you need to program a flow table, you need to add flows, and at that point you need the OpenFlow plugin. And the OpenFlow plugin 1.3 is available in the OpenFlow plugin repository, and any application you build can use that plugin to be able to program the OpenFlow rules. So the logical sequence for most application will be to set up the bridge using the OVSDB plugin, and then associate a controller. And after a controller is associated, you most often just use the OpenFlow plugin to program rules. And whenever there are changes in the individual ports, or there are changes that happen in the actual physical or OpenV switch, you would get notifications which you can act upon. Just one last piece I do want to mention here is the MDSAL adapter. So there have been a lot of additions now made to essentially export all this information in the cache into the MDSAL operational data store. And for that, there is a YANG model that has been built, and there's a translator provided so that any information you have inside the cache is exported to the MDSAL data store. And all the callbacks are performed here. And it is a good idea to have a look at the README, which is in the OVSDB repository. This README has clear information of exactly what each of the directories correspond to. For instance, the MDSAL adapter, like I mentioned, corresponds to transporting information from this cache, the OVSDB cache, onto the MDSAL data store. So this summarizes the view of the overall plugin part of the OVSDB project. I will do another hangout on explaining exactly where the OpenStack integration will work with this plugin. And to be able to support hardware VTEP schema, there needs to be a lot of changes made in this configuration service to be able to handle that schema. For instance, here, all that you need to do is just do a search for vSwitch schema. Have a search for this vSwitch D schema constants database. That will show you all the places where working only with Open vSwitch. For instance, even if I go to update row, this really only works with the Open vSwitch schema. So we need to make extensions here to be able to support the hardware VTEP, and of course ensure that whatever table we are working with is also the table that is supported by that schema. So as long as the higher level application understands that these are two different types of hardware and is able to differentiate the schema, then we can make the plugin more generic and not really be specific to Open vSwitch. There are to-dos in certain places that do mention, okay, I guess right here, which says exactly how some of this is very specific to the Open vSwitch schema. So this needs to be addressed for Lithium. Thank you so much for attending the hangout.